Hello, my friends, and welcome to Origins. It's so good to have you with you. My name's Don Chapman, and I'm the host of Origins. And as you may know, Origins is a forum where we take the evidence of science and we use it to validate the truth of God's creation. Today we have an incredible guest with us. Dr. Steve Austin is back with us, and we are talking about Continental Sprint. And Dr. Austin, it's such a privilege to have you with us. I need to tell the folks a little bit about you. You're a PhD from Penn State. You're a field research geologist and the senior research scientist at Institute for Creation Research. And you have been on 6 different continents, and there are only 7 as far as I know, digging in the ground and finding truth. Incredible work you've done, both at the Grand Canyon and at Mount St. Helens, that has made you respected across the geological community. We're really honored that you're here.
It's good to be here to share these things with you.
You believe there was a time when the Earth mass was one big continent.
I do, and I think before the flood and from Creation Week, there was a big central continental mass to the crust of the Earth. And then during the flood, that continental mass broke apart. It didn't drift apart over hundreds of millions of years. It broke apart and moved at a fast walking pace, like we could call it Continental Sprint.
Very good. And one of the tools that you've used in this incredible research that you gentlemen have been doing for some time is computer models. Is that right? That's
right. And we have state-of-the-art computer modeling in our research group. One of our researchers is a geophysicist, and he specialized and actually did his PhD dissertation on making a computer model of the mantle of the Earth. Here you see this graphic that shows how a computer model can be made of the inside of the Earth. It's a 3-dimensional computational mesh formed out of little prisms, and you see the triangular prisms and how they're stacked up there, modeling the core of the Earth. And the crust of the Earth is kind of riding along with the mantle.
So the green on the outside is the crust. And the purple dark is the mantle, and that's what we want to look at.
And it looks like we got 174,000 little prisms sitting in there.
Wow.
Each one of those has a temperature. Each one has a pressure. Each one has a viscosity. Each one has a velocity. Each one has a density. And so all of the properties of the Earth can be put into this computational mesh and used to model. This is a flat view of the 3-dimensional mesh at the surface. And what we're modeling here is the pre-flood configuration of the continents versus the present configuration of the continents. So you can see the initial configuration. You can see North America, Africa, South America, and Europe and Asia kind of drawn together there. There's a wedge-shaped kind of area called Tethys here. There's Antarctica, there's India and Greenland, and so you can see how they kind of fit together. The modeling begins with this kind of configuration, and then we allow it to deform. The mantle of the Earth deforms as the ocean floor is subducted under the margin of the supercontinent. Let's take a look at it in cross-section. What we are modeling here is the ocean floor around the Pacific Basin falling into the mantle of the Earth. And you can see where 2 places where cold ocean floor, blue color, is falling into green. That's colder, higher density material it wants to fall. And so the falling ocean floor into the mantle causes subduction, mantle-wide flow, the flow of the mantle, you see those little vector arrows, and then it creates these places where we have upwelling of material. And that's spreading. So subduction, where cold material is falling, ocean floor, mantle-wide flow, and then rising material creating new ocean floor. That's spreading. So that's 20 days into the modeling experiment. You can see what happens. The ocean floor falls. And at 60 days, basically the ocean floor has penetrated the mantle and is sitting there at the core mantle boundary. We don't think it enters the core of the Earth because it's very high density down there, but it fans out. And it creates this remarkable process. Here you see a map view of what we're trying to model, not cross-sectional view. Here it is at 20 days. You can see the supercontinent is opening up, and you can see the fracture zone along the mid-ocean between the continents of North America, Europe, Africa, South America. And so you can imagine this. And you can see the upwelling occurring as the spreading seafloor is happening. And you can see where the blue areas where around the margin of the continent where colder crust is being subducted. Here it is into about 40 days, and you can see in 40 days the Atlantic basin is opening up. There's the new ocean floor that's forming as this is happening. There's subduction around the margin of the supercontinent all around, and then there's mantle-wide flow and then pulling apart of the continents. Huh. And that's modeled on high-powered computers using this computational mesh. And that's the interesting thing. Okay, that's 40 days, and at 60 days, you can see what's happened. There's significant spreading. How long does it take for the Atlantic Ocean floor to form and the Pacific Basin crust to be subducted? Essentially 1 year, which is the duration of Noah's flood. Noah's flood lasted on the earth over a year.
The rain came down for 40 days, but the flood, the earth being covered with water lasted a little over a year.
Yeah, Noah was in the ark over a year.
Yeah.
And so where would be the only place you could survive on a planet going through a catastrophe like this with Continental Sprint?
Well, it couldn't be on top of a mountain because they're all buried underwater.
Right, so if you were in a big boat, well provisioned with food, you could survive.
Literally, the only place on Earth you could survive would be a battleship.
There would be continuous Richter magnitude 8 earthquakes.
Wow.
Okay, not from points, but from lines all around the continent. So you imagine the tectonic catastrophe that we're modeling here. And here you see velocity vectors put on the map view. And this is looking from the equator at 60 days. 60 days, you can see the ocean basin, Atlantic Ocean basin again, right in there. See that Atlantic Ocean basin forming as those continents have moved apart? 60 days into it. I got another view here. Here's the polar view. We're looking down at the North Pole, and we can see the Arctic Ocean forming. And that's and the velocity vectors. The velocity vectors are about 1 meter per second, 3 feet per second, something like that's the velocity that these plates move. So they get to moving, and then they reach this terminal velocity of about 1 meter per second. And the plates fall into the mantle about the same rate, about 1 meter per second. So that's a fast walk, or we could call it what? Continental Sprint. It just kind of follows as you begin with that configuration. You can cause the Earth to deform, and it ends up with what we have today, the continents distributed widely. It's the ocean floor, the cold ocean floor, that actually sinks into the mantle, and it drives global tectonics.
Makes sense.
Okay, Continental Sprint. I would just like to take you back to reality, away from the computer again, to a spherical Earth. He's got the whole world in his hands, right? Yeah, the spherical Earth. But notice that the mountain basins around the Pacific are what? A line across there. There's a great circle upon which the ocean floor and the continents interacted with each other. And you see that in the views. Again, you can draw a line right along, through North America, from Asia all the way down to South America. So there is a boundary along which this deformation occurred. And we're looking at, of course, the Pacific Basin up against North America here. Here you see California, Oregon, Washington, British Columbia, and up to Alaska. So there was a head-on collision between Alaska and the Pacific Ocean floor as the ocean floor was subducted directly under Alaska. And there was a sideways collision, a kind of a glancing blow with California, creating the Great San Andreas Fault. But the big mountain range is over there in Alaska, where the head-on collision is. And the lower mountains are out here in the western United States. So you can imagine Alaska being the collision. And of course, all along the the western part of North America, being this collision zone between the Pacific plate, which was subducted underneath the western part of North America, and the North American plate, the granite rock. Look at the high areas in Alaska, the Bagley ice field, and we're looking at those high mountains, thinking about the tectonic process that uplifted those. Those mountain ranges contain marine fossils and have been made by the tectonic process. This illustrates the conveyor belt. As ocean floor splits apart and falls into the mantle of the earth, it creates a conveyor belt. Okay? The edge of the continent is down warped by the falling ocean floor next to it, and the ocean floor is up warped as it's trying to arch and go down, so it creates a scraping zone, scraped off sediment. And what? The ocean floor, this new ocean floor that's created, is lower density because it's hot, and it lifts the ocean basins, and so the ocean is driven onto the continent. And so we have this conveyor belt and this ocean flood that's going over the continental material. And so we can imagine tidal waves, huge tsunamis.
And a whole lot of shaking going on.
And what do? We deliver sediment to the edge of continents.
Sure.
And then we pile it up on the continents. So we have a way of explaining the continents. Lots of interesting things here, like in the Grand Canyon, giant boulders at the base of the flood strata sequence, 20-foot diameter boulder sitting right there. There's a man for scale.
Yeah.
The Blandin sluggard boulder doesn't move, and you got to give it a big kick when you move big boulders. And so these are powerful tectonic forces that are shattering rocks and redepositing them in giant slurry flows. There is a mountain right here that I'm looking at, okay, that's over 1,000 meters thick right in there, that was redeposited on the seafloor. It slid as a giant rock mass. Wow. And it's associated with a whole bunch of other boulders. And so there's a collapse and flow of the seafloor and of the edge of the continents. Here we see in California rock that's been shattered, dispersed, and then deposited in the deserts of California. We can see sandstone layers with that diagonal layering in it. Looks like the form of dunes. Those are underwater sand waves, and the current moved from left to right here. There's a man right there for scale. Okay, and think of that. Those are big underwater dunes that were moving along as sand was flowing in a current, moving pretty fast. Fast-moving current is sweeping sand over the ocean floor. We see that all around us. We see evidence of catastrophic sand deposition. There is a layer of sandstone that's in the Grand Canyon in California that can be traced through the North American continent, around through Canada, up to North Greenland. And it can be followed through the central United States over to Newfoundland. And the same sandstone appears in the British Isles, in Cambria, in Wales, and it occurs in Nova Scotia and next to it, and in Scandinavia. So you could imagine putting Europe up here with another sandstone mass. So the Canadian Shield is surrounded by this giant mass of sand. A colossal, very thin but widespread mass of sand.
And all of that was moving under the water during the flood.
During the flood.
Yeah.
And so the massiveness of the sand that's moved and its wide distribution argue for a global flood.
Yes, sir.
And think about the fossils and the logs. For example, petrified forest in Arizona. We see a whole bunch of petrified logs, but it's really not a petrified forest. It's a petrified log jam that was floated in. So we see a lot of floated material dragged along by currents. And coal mines. Coal is, and limestone and shale strata are associated with the flood. I believe that great log mats of debris were floating around, like in the central part of North America, and everywhere these log mats floated, particles of of bark and other material rain down, and sometimes we form coal beds very rapidly by floating log mats. And dinosaur deposits were swept, bones of dinosaurs and carcasses of dinosaurs were swept up. We see here a tail section of a large dinosaur.
Yes.
A carcass, but it was shredded carcass, but the individual bones are still attached. So ligaments and muscles were there. So we see shredded dinosaur carcasses and pieces of shoulder and tail and backbone, all kinds of things here in this deposit. It looks like a giant mud flow swept up these dinosaurs. And this is, of course, Dinosaur National Monument. It's 1,500 bones on that wall, wow. But it provides an evidence of a slurry flow that buried dinosaurs. So things were not calm and placid when dinosaurs were being buried.
It gives the word catastrophe a whole new dimension almost, doesn't it? Beyond our imagination.
Yep. And I'll call your attention to marine fossils like clams. In Texas, there's a layer 3 feet in thickness here of limestone with clams in it. And that clam layer is composed of what? Just almost completely clams. But the clams have their valves both sides together, and there's a hinging ligament in between the shells that keeps the shell together. And of course, when clam dies on the beach, it falls apart. But here's a layer of clams killed by being buried. They didn't fall apart. And so the muscles and ligaments were attaching those together. So the fossil deposits are really remarkable.
We got to talk about the part that volcanoes and earthquakes played in all of this, but before that we have to take a break. So you stay at the board and you stay right there. We'll be right back.
Today's guest on Origins, Dr. Steve Austin, is a field research geologist with his PhD in sedimentary geology. He is senior research scientist with the Institute for Creation Research. He has been involved in geologic exploration for 40 years on 6 of the 7 continents of the world. Steve has also done extensive field research at the Grand Canyon and Mount St. Helens. He is the author of several books, videos, and more than 30 technical geology papers. One of his books, Footprints in the Ash, deals with the 1980 eruption of Mount St. Helens. Dr. Austin can be reached at Institute for Creation Research, 1806 Royal Lane, Dallas, Texas, 75229.
Back with Dr. Steve Austin, and we've been looking at a computer model that showed what it must have been like when the continents pulled apart as a part of the worldwide flood. Dr. Austin, talk to us about the volcanoes and earthquakes and the part they played in all of that.
Well, volcanoes and earthquakes would be obviously one of the most important aspects of catastrophic plate tectonics, or Continental Sprint, as we call this. Lava flows, when they crystallize, when lava crystallizes to form a rock, molten rock crystallizes, it retains in it the magnetic field of the Earth when the crystals form. And so cooling basalt records fast reversals of the Earth's magnetic field. We believe that during catastrophic plate tectonics, during the time of Continental Sprint, something was going down at the core mantle boundary that disrupted the Earth's magnetic field. And the Earth's magnetic field flipped repeatedly, and it left a signature of the catastrophic change in the basalt layers, in the lava flows that crystallized. And so there's one lava flow on Steens Mountain in Oregon that is a single lava flow that records in itself the reversal of the Earth's magnetic field, evidently.
Wow.
An astonishingly rapid field change, according to the specialists who were studying the magnetic properties of the basalt layer there on Steens Mountain in Oregon. And looks like the lava flows give us a magnetic record of how the Earth's magnetic field changed. And the floor of the ocean, like the Atlantic Ocean floor, contains a tape recording, essentially, of the fast reversal of the Earth's magnetic field. So I've talked to you a little bit about volcanoes and how the lava flows provide evidence of the magnetic reversals. Then I'll call your attention to the Pacific Ocean basin. And it's been called the Ring of Fire, hasn't it? All those volcanoes around the Pacific Rim. And the earthquakes around the Pacific Rim. So earthquakes and volcanoes are all the way around the rim. But it's not really a ring of fire, it's a basin of fire, because there's thousands of volcanoes all over the floor of the Pacific Basin. Hawaii is just one that sticks up. And so these volcanoes on the seafloor are showing us the new ocean crust that formed as a result of the catastrophic plate tectonics associated with Continental Sprint. So these earthquakes are associated with boundaries of plates like we see here.
So we're imagining all of this happening, and it's happening pretty rapidly in a period of a year. When the flood's over, what happens?
Yeah, the flood just doesn't go back into its basins immediately. The water of the ocean doesn't go back. There's some things that happen. And let's take a look at the statements of Scripture. Let's think about the space that's made for the accommodation of the ocean. And let's talk about the beveled surfaces of the continent, which may provide evidence of the retreat of the flood. Those are some things to think about as the flood terminated. This scripture passage in Genesis 8, verse 3, and Genesis 8, verse 5, the waters retreated from the earth, going and retreating, and the waters were going and falling until the 10th month. After the 150th day of the flood, as the waters are starting to retreat, then the waters are retreating from the earth, going and retreating. And literally, that's the way to take that Hebrew text. And it sounds like there's some type of oscillatory motion, the waters coming and going over the earth as the waters are retreating. And so I like to think about that verse, especially as I look at some places like the Grand Canyon itself. And there you see the plateau in Arizona. The planar surface of the upper plateau of the Grand Canyon region looks like it's been sheet flooded, and the erosion of the plateau by the retreat of the floodwaters. So it provides evidence of the flood in the strata and then the retreat of the flood in the beveled surface of the plateau.
So you see both there. You know, this is, again, I just have to say to you that I believe the Bible, I believe in the young earth, I've always believed in Noah's flood, but I don't think I've ever been able to imagine the catastrophe and the trauma of what Noah and that little group of people on that boat are living through and what's going on around them. If ever there was a time to trust God, I think that we don't have to worry about their prayer life. I think they had to be praying pretty fervently as they were on that little ark of safety in the hand of God in the midst of this total reshaping of the earth. The whole earth is literally reshaped during this time.
70% of the planet's surface was subducted. Only the continents remain, and they've been broken apart and distributed over the surface of the earth.
So when Noah walks off that ark, he has no idea where he is, does he?
It's a new world.
It's
a completely
whole
new world.
And the only thing he knew was that God had preserved him and he was there. And you know, my friend, I just want you to remember as we wrap this show up that the further we look and the more scientific tools we're given, the more veracity we see in the Word of God. You know, you can be like Noah. You don't walk off an ark today, but you've got to walk in faith every day, trusting that God goes before you. And you know, Jesus is our ark of safety. You need to walk in faith just as Noah did. We don't know what's coming. We don't know the world ahead of us, but we know the God that walks with us. And so always remember this, my friend. It's God's view that He created you. You can trust Him, so that should be your worldview too. Hope you'll join us again soon here on Origins. And until then, God be with you, my friend.
Thank you for watching this edition of Origins. To get a copy of the information presented today, you can download a PDF file of program number 1115 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 1115, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.